Example 8.9 brings us to the end of section 8 and the last example for application. It says here an isosceles triangle containing two angles with equal measure is shown. The degree measure of each triangle's three interior angles and an exterior angle is represented with variables. Now, with all of that said, the picture describes everything that's there. So it then says find the measure of the three interior angles. So that's going to be the x, the y, and the y that's there. On the previous application problems, 8.8 and 8.7, we had to actually write out what the variables represented. Here we don't have to do that because the picture already says exactly what the variables are going to represent. X represents this angle at the top inside of the triangle. Y represents this bottom left angle in the interior, and Y can also represent the bottom right angle in the interior of the triangle. So we have the variables already defined for us, and there's only two types of variable here, X and Y. So when the Y shows up twice, we don't have to count that as a third variable, which is good news because now that means we only need two equations. So we'll just use the two equations that we come up with to solve the system. So there's some things that we have to know about a triangle. For starters, the three angles that are on the interior, the X, Y, and the Y. There's a property of triangles that says those three angles have to sum to be 180. So that would be X plus 2y has to be equal to 180. So that's one thing. Then I'd want to look at a straight angle. Now, to think about a straight angle properly, if you think about a circle, circles are known as a 360 degree. If you make a full circle turn, that's 360 degrees. If you take a half of a circle, semicircle, that would have to be 180 degrees. So if I think about that half circle sitting on top of a straight line, then I can take this straight line and use it as a base for the angles, and I can take it and split it somewhere, and I can turn it into two separate angles. But if I take those two little angles and put them back together, it's still going to take all the way across and make it 180 degrees. So we have such a situation right here in that bottom right angle with the y and the 3x plus 15. If I put both of those angles together, I'm going to end up getting 180 degrees. So I can create a second equation by saying y plus 3x plus 15 has to be equal to 180. So then I would take the second equation, the one that we just wrote, and I would simplify it. And the way that I would simplify is I would subtract 15 from both sides, and I would also switch the order of the 3x and the y. So I would write it as 3x plus y is equal to 165, and then I wouldn't do anything to the second equation. I'll just make it x plus 2y equals 180. And that represents our system. And from here you can pick whichever method you choose to do your solving. You can either do substitution, solving for the x, or solving for the y. Either one of those would be excellent choices. Or you could try to eliminate the y's or eliminate the x's using the addition-elimination method. So I will pause here and let you work through this on your own. And once you are done with that, let me give you the answer. The answer is that the three interior angles measure 30 degrees, 75 degrees, and 75 degrees. So whatever method you choose, you should be able to get that x is 30, y is 75, which means the other angle of y is also going to be 75.